Let's discuss the third problem of today's weekly contest. The problem states that we are given a array of integers and we are given an integer k. We need to perform exactly k moves. In each move, we can either remove the topmost element of the pile. Topmost element denotes the first element in the array, or we can add back any of the removed element from the array. So for example, let's say if we have removed these three elements by using operation 1, then we can add either 5 or 2 in back to the array as per the operation 2. Now what we need to find is we need, after performing exactly k operations, what will be the largest value that we can take on the top of the array. So in this case, k is 4. So we have to perform exactly 4 operations. So how they have performed 4 operation is they have removed 5 from the array first, then they have removed 2 from the array, then they have again removed 2 from the array, and then they have added 5 back to the array. So the new array is 5406, and we can see the topmost element is 5. So that's why the answer is 5. So how to solve this problem? So let's try to understand it with an example. So we have two operations. One is to add an element in the front of the array, and then second is to remove an element from the front of the array. So removal is straightforward. Whatever will be in the front, we will remove it. Addition is quite interesting. So basically, let's say we have done some removal operations, and from removal operations we have got already 6, 7, 2, 1, 3, and one more 3, and then 6. So we have got this many elements after some removal operations. So while adding back, what you will try to add? So the claim is we should only add the greatest element back to the array if we know that, like, we are sure that we are adding to the front of the array, right? So why to add a smaller element to the front of the array if we want to make the first element largest? So our answer is basically to maximize the first element of the array. So while adding back any element, we should not add the smaller elements. So that being said, like, I'm sure you can also find it intuitive, because adding 3 will not make sense, because in that case adding 7 will be better, because 7 is exposed in the front. Now there are two cases to this question. One is k less than equals to n, and another is simply k greater than n. So why these two questions, while these two cases? The reason being, in this case we are not removing every element from the array, but in this case we can perform n removals to remove everything from the array and then rebuild the array from the scratch. So that's why we have divided this into two cases. Now let's first analyze this first case where k is less than equals to n. So when k is less than equals to n, what we can do? We can either perform k removals, or we can perform some removals and then some additions. Now, with this argument where we are saying that okay, we will add only the largest element, it will make sense to maximize this largest element from the array, right? So if there are more number of elements in this bag of removed element, then we can find out the larger element. Like the larger element can also be larger. So let's say you have explored this much array. Now if you explore some more array, there might be chance that you will get larger element in the further side of the array. So we will always try to explore as much elements as we can while traversing the array. So when k is less than n, we can, what we can do is basically, let's take a specific example. Let's say k is 5. So in this case, what we can do is remove the first k minus 1 elements. So basically what we are saying is we will perform k minus 1 removals, and then for the kth operation we can perform either addition or removal based on some factor. So what is the factor? So we have performed k minus 1 removals. So we have removed 5, 6, 2, 4 from the array, and from this we get the maximum as 6. So while adding, we will add back 6. Now either we can add 6 or we can remove 3 in kth operation. So removing 3 will expose 9, and adding 6. So if we remove 3, array will be 9 and 8. This will be the final array. But if we add back 6, the final array will look like something 6, 3, 9, 8. Now among these two, the larger is 9 in the front. So we will perform removal here. Now let's explore one other example wherein k is 4. So if k is 4, we will do similar thing. We will remove first 3 elements, like we will do 3 removals from the array, and from this we will get maximum as 6. And for the kth operation, we can either remove 4 or we can add back 6. So either we will have 3, 9, 8 as the final array, or we will have 6, 4, 3, 9, 8 as the final array, right? Now which one is better? Basically this one is better because 6 is larger than 3. So in this case, we have performed addition instead of removal as the last operation. So this case for k less than equals to n, this case is clear that we will perform k minus 1 removals first to explore as many elements as we can, and then for the kth operation we can do either removal or addition based on which is better. Now coming to the other case wherein k is greater than n. So in this case we can extract, basically we can remove every element from the array because k is greater than n. So we will remove everything from the array, and by removing everything from the array we will be sure that we will get the maximum possible integer from the entire array. Now after getting this maximum possible value, we are left with n minus k operations. Now how to perform this n minus k operation? So let's say n minus k is odd. So if it is odd, what we will do is we will add, let's say this is 9, so we will add 9, then remove 9, again add 9. So this is 3 operations. Again we'll remove 9, add back 9, 5 operations. Remove 9, add back 9, 7 operations. So basically what we are doing is we are adding and removing the same element, which is the largest element from the array, and this is the best possible scenario. Now let's assume the other case where n minus k is even. So in this case, let's further like, because n is greater than k, so n minus k will be at least 2. So it can be 2, 4, 6 and so on. So in this case what we will do, we will add anything from the array. Let's say we will add 2 from the array, and now we have done one operation. So we have made this n minus k from even to odd, and notice that we haven't added the maximum element. In this case we have added some other element apart from maximum element. Now n minus k is odd, so we will, after this we can perform the similar trick which we have done when n minus k was odd. So this, for this possible scenarios, we are assuming that there are at least 2 elements from the array. So there is one more case wherein n equals to 1. So in this case we will handle it explicitly, because with n minus k even we are saying that we are first adding something which is not maximum, and then we are playing with maximum, like removing, adding, removing, adding. So coming to the code, so the code is very simple. As discussed, we have handled n equals to 1 case explicitly. So basically we are saying if k is odd, then remove return -1 because we can't actually get anything on our plate. And if k is even, then we can just remove the only element and then add the only element because there is only one element. Now if k is 0, we can't do anything, we return 0. Now as discussed, we are taking the minimum over first k minus 1 elements or n elements depending on which is smaller. And if k is less than n, we are checking the both the scenarios. Basically remove the kth operation can be either removal or addition. So based on whichever is maximum, we are returning that. And if we are not if k is greater than n or equal to n, we are returning this maximum. You can see everything is returned maximum. I have done this during the contest because I was just trying to evaluate all the possible scenarios, but this entire thing can be just return max and it should also pass. So this is the code. Hope it is clear.